Okay, now let's move on to the first effect. Okay, the first effect it can change speed. So this is the first effect that we have here, changing speed. So how does it change speed? Because forces can produce this thing called acceleration. And now you know why force has such close link with kinematics. Because forces can change speed and affect acceleration. Okay, this is why we always link forces with kinematics. This is a very common question that always comes out. So now, how does force affect speed? You know that, okay, you will see this formula here. Resultant force, okay, take note, resultant force is equals to mass multiplied by acceleration. Okay, typically all of you memorize it as F equals to ma. One thing you must always remember that the F that we are talking about here is the resultant force. Okay, what is resultant force? Is the net force. That means you talk about cancelling different forces out. Okay, for example, left against right, you must find out what's the effect of the overall effect left. Now, for resultant force equals to mass and acceleration, how do we go about tackling such questions like this? So, example, a box is pushed with a force of 100 Newton on a smooth surface. Okay? If the mass of the box is 2 kg, calculate the acceleration. Now, so what are the things to take note here? We know the force is 100 Newton. Next thing, we know that it is 2 kg. Okay, so the force is 100 Newton. This is F. This is 2 kg. Here is the mass. Okay, the question asks you to calculate the acceleration. So we want to find out what is the acceleration. There's actually one very important keyword here which people always miss out, which is this, smooth surface. Why is it important? Because when you see it as a smooth surface, means that normally it implies that there's no friction. It means that there's no opposing force. But if there's opposing force, that means my resultant force is no longer 100 Newton. You have to go and find out what is the opposing force to find out what is the resultant force. Okay, so take note, this smooth surface here actually is quite important. Now, so let's look back at the questions. How do we go about tackling it? So F is 100 Newton is equals to mass, which is 2 kg, multiplied by A. So A is equals to 50 meters per second square. Per second square. Okay, take note of the units here. Mass must be in kg, force must be in Newton, and your acceleration will be in meters per second square. Okay, so this is the result of using 100 Newton on a 2 kg mass. So this is how you can go about talking about how the speed changes with acceleration. Okay, how the speed changes with acceleration using how force affects it. Okay, how force affects it. Now, let's continue to go on to the next part. Okay, the key here, we know that if there's a resultant force, there's acceleration. What if there is no resultant force? Okay, what happens? Okay, when there's no resultant force, what happens? The key here is this. You know that if there's a resultant force equals to acceleration, so that means if there's no resultant force, which means that there's no acceleration. If there's no acceleration, there's two different results here. It can be either object remains stationary. Okay, let me erase so I don't need to use either. We just put object remains stationary, or object moves with constant speed. So sometimes this is summarized as, okay, sometimes this is summarized as object remain, continue in the states of motion. Object, sorry, remains slash continue in its state of motion. Okay, when you say remain in state of motion, in this case not moving, it is stationary. Or if you move at a constant speed, it just continue moving at a constant speed. Okay, so object continue or remain in a state of motion. This is another way that sometimes you will see it being written. Okay, so no resultant force equals to no acceleration. So sometimes in your question, you will see that the object is moving at constant speed. What does it imply? It implies no acceleration, which implies that there's no resultant force. Okay, this is an important concept here. Why? Sometimes they like to draw this kind of question. For example, it has a block that's being pushed, maybe for 100 Newton. Then they say the object is moving at a constant speed. So this is where your brains will start to think, oh no, constant speed tells me that there's no resultant force. Okay, constant speed tells me no resultant force, which means no acceleration. So if there's no acceleration, but yet I have 100 Newton, there must be an opposing force. Okay, this implies that there must be an opposing force. So where is the opposing force in this case here? The opposing force actually is due to friction. As long as object is moving along a surface, okay, there's bound to be friction. Unless it is a very, very smooth surface, otherwise there's bound to be friction. And this friction here, what's the value of it? Remember, there's no resultant force. So if my forward force is 100 Newton, how to make sure that there's no resultant force? It must mean that my friction is also 100 Newton. Okay, so this is how you can imply, okay, how you can apply it when there's no resultant force.